Okay, so chapter 4 is about functions and what we do with functions. So, actually, before we get started with chapter 4, we need to talk about why we graph. Um, we've been graphing a little bit here and there, and we start to get more into graphing in this chapter. And then after this chapter, chapter 5 deals with graphing a lot. So, why do we graph? Well, the answer is when we start to work with graphing equations with two variables, we have ordered pairs that make equations true. So like maybe like 1 comma 2 is an ordered pair that would make some equation true. And then maybe 2 comma 4 makes the same equation true. 3 comma 6 makes the same equation true. So we're going to have a lot of ordered pairs that make some equation true. So what we do is we make a graph that shows all of the ordered pairs that make this equation true that we're looking at. Okay. And what the graph does is it gives us a visual idea of a pattern of ordered pairs that make the equation true. So that's why we graph. It's easier to visualize the pattern that's going on with these ordered pairs that work for the equation rather than trying to just sit there and look at a whole bunch of ordered pairs in some kind of a table. So that's the idea. Now, if you can keep that in mind as we go through chapter 4 and then again in chapter 5, and never lose sight of the fact of why we graph, then these two chapters coming up, and really anytime we graph anything in algebra or geometry or algebra 2, your life is going to be a little bit easier. So just kind of keep that idea in mind. We're graphing for a visual idea of what the solutions, the ordered pairs that work, are doing. Okay? So let's take a look at this problem here. The graphs below relate the height of the water to the volume of the water in each container. So if you look at those containers, imagine filling them with water. Okay? So you have a little stream of water going into each of those containers, and each stream is equally pouring into each container. So which graph goes with which container? And then justify your reasoning. So when you see justify your reasoning here, that is saying explain how you know. Okay. So let's take a look at the graphs and see if we can understand which one goes with which figure. So looking at the first shape, um, or let's take a look at the first graph. If I'm looking at this graph right here, which one does that have to go with? Well, if you imagine water pouring into these three containers, so if I call this figure, this container A, this container B, and this container C, I think it's pretty clear that this one has to go into container C, right? Because if you compare this region right here, if you compare that region to this region, the volume on the horizontal axis to the height on the vertical axis there is, it seems like we're getting more height more quickly on this first graph compared to the height here on the second graph, right? So that should indicate to you that we're getting more height more quickly, meaning that the container is skinnier than in this one than it is on this one. Okay, so the container on the first graph must be skinnier than the container on the second graph because the water is filling the container so much more quickly. Okay, so that means that this first graph must be either container B or container C, not container A. In fact, we can probably say that this must be container A at this point, okay, because of how slowly it's filling, because it's so wide. All right, now, if that's the case, then which one, the far left graph or the far right graph, is container B, and which one is container C? Well, container C has this widening part right here. So by the same logic that the middle graph is container A, it's filling slowly, so this line is very shallow, we'll say. As we get over to container C, where we are narrow here, but then wide here, we should be filling quickly in this region, But then by the time we get up to the top, we should be filling very slowly. Okay, so that means a steeper line here and then a shallow line here. So this must be container C in this first graph. Okay, so that's why we put C there. And now that kind of leaves container B for the third graph as the last choice. And because this is a straight shot here, okay, and it's narrow the entire time, then we must be filling quickly the entire time. And that's why this is just a steady, fast, steep line the entire way. Okay, so that's the kind of thing that we're going to be doing sort of off and on this chapter, is analyzing the graph. And really just in this section, pretty much this whole section is representing the relationship that we're looking at using graphs. Okay, so that's the whole idea in this section, is just kind of thinking about the relationship that we have and kind of looking at a graph and making some sort of graph based on what we're looking at for the situation. Okay, so we're using graphs to represent relationships between two variable quantities as they both change visually. That's the whole idea behind graphing anyway, is what's going on in the situation. Let's make a graph so that we can represent that visually. Okay, so that's the idea in this section. So let's go on to the next thing. So the graph here is showing the volume of air in a balloon as you blow it up until it pops. So I'm sure we've all blown up a balloon before, or at least we've seen one. So try to visualize that now. And as we're looking at graphs, you try to visualize, if you have real life experience with any of the things that we're talking about, you always try to visualize that as you've seen it before. It'll help a lot. Okay. So in this case, we're blowing up a balloon. So if you've done that before, you try to visualize that. You try to bring up that memory. If you've never done it before, you try to imagine somebody doing it. You've seen it before, that sort of thing. Okay. Now, maybe you've never blown one up until it popped. Maybe you have. Okay. You try to bring up that memory. So what are the variables here? Well, the variables, if you look at the graph, are going to be written on the axes. Okay, so the variables are going to be volume of the balloon, and time. Okay, so we're talking about the air that's in the balloon. The things that are changing are the volume of the balloon and the time. As time goes on, the volume of the balloon is changing because we're blowing it up. Okay, that's the idea. So now describe how the variables are related at various points in the graph means what we're going to do. So now I'm answering this question here. Okay, describe how the variables are related at various points in the graph. What we're going to do is we're going to look at the graph and we see how it's kind of climbing and then it levels off. Okay, we're climbing here, we level off. We climb and then we level off. We climb and then we level off. Okay, so it's asking us to describe what's going on in each of those situations. Okay, so what's happening every single time we climb? What's happening there and there and there and there? What's going on there? So yeah, we're blowing up the balloon. Okay, every time the graph climbs, we're putting air into the balloon. We're blowing it up. All right, we're breathing air in to the balloon. So blowing up, balloon. So then the big question is what's happening at these horizontal locations? So there's a horizontal spot there, horizontal spot there, horizontal spot there. Those are three key locations on the graph as well. So we need to say what those are. And those, yeah, those are going to be, we're taking a breath. Okay, as you blow up a balloon, you put all the air that's in your lungs into the balloon, you got to take a breath of air. Time is still passing, so while you're not blowing up the balloon anymore, the volume of the balloon cannot increase, so hopefully you're holding, you take your fingers and you pinch off the air in the balloon so that the air doesn't come back out, so the volume doesn't increase or decrease, so it just stays steady while time passes, so it stays horizontal there. Okay, now, what happens right here at this location? And how come the graph drops all the way down to 0? What happened right there? Yep, the balloon popped. Okay, so now we have a description of how the variables are related at the various points in the graph. That is what you're supposed to do when it tells you to describe how how the variables are related at various points. Okay. So we have a couple more examples. Let's take a look. This time, what are the variables in each graph, and describe how the variables are related at various points on the graph. So let's take a look at A. The variables, it says board length is the title. So what are the variables here? The length of the board and time. Okay, and let's describe what's happening at each of these key points, or key locations, I should say. Okay, so these horizontal spots, what are we probably doing? Actually, let's talk about this one right here. What is that particular horizontal? That's going to be the original length. Okay, now what is happening at these vertical spots right here? Here, here, and here. What's going on right there? Okay, we're making cuts because now the length of the board is changing. So cuts. Okay. Now what's happening as time is going on, the length of the board is not changing. What's happening at these horizontal locations here and here? What are we probably doing in between those cuts? Measuring. For the next cut, probably, right? Or we're lining up the next cut on the saw or something. Okay, something's happening there though. Okay, it takes time, whatever it is. So we have to say what it was that we were doing. Okay, and now what happened right here? What's going on there? Okay, we're done. No more cuts. Okay, so that's the idea. Okay, so now B here. June's cell phone cost is what it says. So what are the variables? The cost, what? Cost of our phone. Okay, and what's the other one? Minutes of calls. Okay, so minutes of calls. Now, this probably doesn't really make much sense to you guys now because everybody pretty much has unlimited minutes on their phones. A few years ago, maybe 10, 15 years ago, this would have made a lot of sense to everybody because you had a plan that made you not able to just call anybody and talk forever. And actually, probably you guys don't even talk on the phone anymore. So, what would make more sense rather than minutes on your phone would be probably like data, right? So, data used, something like that. Most of you, well, some of you probably don't have unlimited data anymore. So, for me, this would be like when I first started out, when texting first came out, you couldn't send too many text messages. In fact, the first plan that I had that had text messaging on it, I could only send or receive 4 text messages in a month. Imagine that one. And anything over 4, I got charged 25 cents. Imagine that now. You guys probably sent 4 text messages like in the last 30 seconds. So, yeah, it was crazy. So anyway, um, what's going on here? Let's say that this is data instead of minutes of calls. What's happening there? In that region, we have not gone over allowed. Now, in my idea of in our current world, this would be data, but for this problem, it's have not gone over the allowed minutes. Okay, but now it would be data. So then what happened here? Yeah, now we're over. So like right there, we reached our minutes maximum or our data limit, right? And now we're over, and we're gonna start getting charged. Okay, so we're not using Wi-Fi, and now we're gonna start getting charged. So what are we gonna say here? over the limit, and now getting charged. Okay. People used to get crazy phone bills. Like you used to pay like $50 a month or something like that, and I had friends that were getting $200 or $300 a month in their phone bill because they were sending so many text messages when texting first came out. It was super popular, and it was crazy. So anyway, probably the same thing with data with you guys now. Okay, so that's the idea. Let's go on. Okay, so matching a table and a graph. What we're going to do is we're just going to look at the data in the table that they gave us, so the table on the right, and then we just look at how we go from one ordered pair to the next to the next. Okay, and we're looking for a pattern. And then we look at, so this is a multiple choice question. So we look at the patterns that are given to us in the graph, and we try to match up what's going on. Okay, so in the problem, it says a band allowed fans to download its new video from its website. The table shows the total number of downloads after 1 day, 2 days, 3 days, and 4 days. Which graph could represent the data shown in the table? Okay, so we look at the table. Day 1, 346 people. Day 2, 1,011 people. Day 3, 3,455 people. Day 4, 10,426 people. Okay, so in general, what's happening each day? Just basic. Basically, we're getting more and more people each day. Okay, so the graph needs to show that we're getting more and more downloads each day. Okay, so look at the graphs. Are there any graphs that are not showing more and more people each day? D shows less and less. Okay, so it cannot be D. So we cross that one off. Next, we say, well, how much are we changing each day? Are we changing by the same amount each day? Okay. Or are we changing by more and more each day? Or are we changing by less and less each day? Okay. So from 1 to 2, day 1 to day 2, we're changing by approximately like 700. And then from day 2 to day 3, we're changing by a lot. It's like 2,500. And then from day 3 to day 4, it's crazy. It's like 7,000. Okay. So are we changing by the same amount each day? If we are, then that's going to look like a line with our dots. And we're not. We're not changing by the same amount each day. We're changing by more and more each day. Okay, so it's definitely not A. Is C showing more and more each day, or is it showing growing but by less and less each day? Okay, C is showing growing but by less and less each day. So it's not C. If you look at B, B is showing growing and by more and more each day. Okay, so like if I draw a line here, okay, and then I draw a line like this, and then I draw a line like this. See how those lines are getting farther and farther apart as we go? That is showing growing more and more each day. So the answer is B. That's what we need. All right. So when I say watch for a pattern, that's the patterns. Those are the types of patterns that we're looking for when we're doing a problem like this. All right. So let's take a look at the next one. It's the same idea. We just want to see what is happening in the data and then make a graph that sort of matches that pattern. Okay, so this one says the table shows the amount of sunscreen left in the can based on the number of times the sunscreen has been used. So which graph could represent the data shown in the table? Well, before we even look at the graph, or sorry, before we even look at the data, if we're using sunscreen that's in the can, how is this going to go? Are we going to have more and more sunscreen as we go, as we use sunscreen in the can? No. So if there was any graph that was showing a growing amount of sunscreen, then that would automatically be a no. Okay. So we look at A, B, and C. We don't see any graphs that are showing growing. They're all shrinking. So that's good. We don't have to cross any of those off. Okay. So they're not like insulting our intelligence by throwing one on there that's growing. They didn't even waste their time with it. That's good. Okay. Now look at the number of uses. We have 0 uses. We start off with 5. 1 use, 4.8. 2 uses, 4.6. 3 uses, 4.4. Okay, so we are decreasing each time. Now the question is, are we decreasing by the same amount each time, or by more and more each time, or by less and less each time? And if you look at it, 5 to 4.8 to 4.6 to 4.4, we're decreasing by like 0.2 each time. So we're changing by the same amount each time. Does A show by the same amount each time? Does it look like a line, basically, is what I'm saying? And the answer is yes. Okay, so it could be A. Does B show that, changing by the same amount each time? No, it doesn't. So it cannot be B. Does C show that? And the answer is yes, it does. Okay, it does look like a line, so it could be C. So the question is then, which one is it? Is it A or C? And the answer is, now you got to look at where the graph is showing that we end up. Okay, we end up with 4.4 in our data. So this graph is showing definitely not at 0. This graph is showing definitely at 0. Okay, so after our fourth use, we're out of sunscreen here. After our fourth use here, we still have sunscreen to go. So the better choice here, even though they both show a line, the better choice here is answer C. Okay, that's the idea. All right, so now we're going to do this problem. This is now where we're going to start making graphs. So we have a model rocket rising quickly, and then it slows to a stop as its fuel burns out. All right, so you're going to try to have to picture what's going on here. So it begins to fall quickly until a parachute opens, after which it falls slowly back to Earth. So it says, what sketch of a graph could represent the height of the rocket during its flight, and label each section. So we're going to have to come up with a graph for this. And really, there's no really perfectly right answer, but there's definitely wrong answers, okay? So the first thing we want to do is figure out what the variables are going to be here. And we want to make a graph. So we're going to draw some axes on here, okay? Now, there's not going to be any negative numbers in this problem. The variables are the fact that this thing is rising, and then time is going on. So the variables are height and time, okay? So we're going to draw our axes here, and my drawing skills are just really incredible. Let me get rid of that, and let me draw something a little bit more straight. So we're putting our axes on here in the lower left-hand corner, okay? Because there's no negative numbers. Now, I said our variables are the height of the rocket and the time. As time goes on, the rocket's going to go up and then it's going to go down, okay? So we need time, because as time goes on, the rocket goes up or down, right? So time is on the horizontal axis and the height is on the vertical axis. It has to be that way. Now, at the start of time here in this problem, it says the model rocket rises quickly, okay? So we want to show that. Now I'm going to pick a color here that makes sense so we can see the difference between the axes and so on, okay? So it rises quickly. That means in a short amount of time, it's going to go up very, very high, all right? So I'm going to show in a short amount of time, it goes up very, very high, okay? It's got to be very steep, very quick. Now, its fuel starts to burn out, so it's going to slow to a stop. It doesn't immediately come to a screeching halt. It just starts to slow down, and over time, it eventually stops rising, okay? Imagine throwing like a baseball or a golf ball way up high into the air. It doesn't quickly come to a stop. It slowly comes to a stop in the air, and it starts to fall back down, okay? So we're going to round this off. It's going to start to slow down, and then eventually it comes to a stop at its peak. Okay, now it's going to start to begin to fall. It begins to fall. All right. Now this thing actually is really, it's going straight up into the air. Okay. Now it's all the way up here. It's at the top of its height. And then it's going to turn around. It's going to start coming straight back down. Okay. That's the reality of the situation. But when we graph it with time on an axis, the graph looks like what we're going to wind up doing. Okay. So keep in mind that in the reality, it's going straight up and then straight back down. All right. So our graph here now, we're starting to come back down. So slowly start to come back down, but then it says it begins to fall, and now it's going to quickly fall. So here we go. We're coming back down to Earth until the parachute opens. So here we go. We're falling back down to Earth, and then all of a sudden the parachute opens, after which it falls slowly back. So we're falling, 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 and then the parachute opens. And then once it catches, now it's going to fall slowly back to Earth at a nice, gentle pace. Okay? So that's the graph. That's the idea. Now, it does say to label each section right here. So we need to do that. So now I'm going to change colors again so that I can label each section. Okay? I'm going to pick a color, hopefully, that you guys can see. So what happened right here? Well, rises quickly. Okay? Now, right here, this key moment, what happened? Right there. It ran out of fuel. Okay? When that happened, once it ran out of fuel, it did not immediately come to a stop, but it definitely did not continue to rise quickly. It started to slow down. So it slows to a stop. Okay? Right there. Slows to a stop. It's slowing down. And now right there, it stopped. Okay? Now, it begins to fall. Now it's falling quickly. Okay? Falls quickly. And then right here, what happened? That's where the parachute opened. Okay? Now, what happened after the parachute opened? Falls slowly. Until it reaches Earth. Okay? So, like this right here would extend over and it reached Earth at that point. So that's how you do that. Okay? You draw exactly what it says. In reality, the rocket went straight up and straight down, but because we're graphing the height over the time, then it's going to look like what it looks like here. Okay? That's the idea. Okay. So we got one more problem to do here, and then we're done with the section. So here we go. You start to swing yourself on a playground swing. So what did I say earlier? We're going to visualize swinging on a swing. All right. I'm pretty sure everybody's done that at some point in their life, or at least they've been pushed. So we're picturing swinging on a swing set. All right. Now, you move back and forth and swing higher in the air. And we all know how to do that, hopefully. Okay. Swinging back and forth, trying to swing higher and higher. Okay. You swing. Then once you get to a certain height, okay, then you stop. You stop trying to go higher and higher, and you just let yourself swing slowly to a stop. I'm sure we've all done that before too. Okay. So now we've got to make a sketch of a graph that could represent how your height from the ground might change over time. Okay. And again, we got to label each section. So what are we going to do? Well, first thing we got to do is put some axes down on this grid. Okay. So again, I'm going to draw my axes. I know I can't really have a negative time, and I can't have a negative height, because if I did, I would be underground. So I'm going to put my axes in, creating an origin that's in the lower left-hand corner here. All right. And now I need to write my variables. So the two things that are changing here are, they're telling me actually in the problem, what sketch of the graph could represent how your height from the ground might change over time. Okay, so they're actually telling you to put time here and put the height here, height over time. Okay, so now we have our variables down, so we can start to make our sketch. All right, now where do we start? So a swing set does not start at 0. Okay, it does not start on the ground. You don't swing and drag yourself on the ground. Okay, you actually start on the swing a little bit above the ground, like maybe right there. Okay, and then you swing backwards, or you start off going forward if you're getting pushed, maybe, or something. I don't know, but your height definitely goes from where I just marked up. Okay, so you're going to go up. Whether you went backwards or forwards, you're going up. And then you get to a peak height and you turn around and you come back down, but you don't go any lower than you started. Okay. And then you're going to go up again. Whether you're going backwards or forwards, you're going up again, and hopefully you're going to go a little higher. And then you're going to come back down. And then you're going to go up again, a little higher. And then you're going to come back down. And then you're going to go up again, a little higher. And then you're going to come back down. Okay. Now, in reality, what are you doing? Well, from the side, you're doing this. You started right here. Okay, we're looking at it from the side. And you went maybe backwards, and then you went forward. And then you went backward, a little higher. And then you went forward, a little higher, backward, a little forward. Okay, that's how you swing, right? We're just going backward and forward. But when you graph it over time, this is what it looks like. Okay, we're not moving forward as we swing. We're stationary as we swing. All right. So understand the difference between these two ideas. In reality, we're doing this, just back and forth. But over time, the graph looks like this. Okay. Now, so we got to our maximum height, and then you slowly swing to a stop. Okay. So we're just going to start coming back down. And obviously, I'm out of room on my grid, but I'm just going to go outside of my grid. We slowly swing to a stop. Okay. And eventually, okay, so I should be kind of following along this line. So I should be down here. Sorry about that. But that's the idea. Okay. Eventually you come to a stop. It says label each section, so let's do that. So what am I doing here? And here. And here. And here. Okay. I am swinging up. And what am I doing here, and here, and here, and here? Swinging down. Okay, that's the idea. Okay, now what's happening here? Okay, what do we do here? We stop trying. Okay, we stop pumping our legs and swinging back and forth, right? We stop trying to swing higher. We're just letting ourselves kind of coast back to nothing. Okay, that's the idea. Okay, now that's probably good enough. Like we get the idea there. All right, now B. If you jumped from the swing instead of slowly swinging to a stop, how would the graph in part A be different? All right, so let's go at our highest point. Let's say our highest point was right here, okay, where my little plus is. Hopefully you can see that right here. Oh, see, I was trying to change colors and I didn't. Okay, right here. Let's say we jumped right there. What would happen to our graph? So picture yourself jumping at your highest point. I'm sure people did that. Probably somebody broke their arm. Would we go any higher than the swing did? Probably yes. Okay, so we're going to go up a little bit higher. Okay, like over here, we would go up a little bit higher, but not much. And then we would come back down quickly, right? And when we come back down, we would come back down all the way to the ground. Okay, that's the idea. It happens fast. We wouldn't be gently floating. We don't have a parachute that's going to work here. All right, so that's the graph. How would the graph be different? Explain. Well, we have a little bit more momentum here. The swing isn't pulling us back, and so we go a little bit more up, and then gravity is pulling us back down to earth quickly. Okay, and it's all the way down to the ground because the swing isn't holding us up from the ground anymore. So that's why. All right, that's the explanation. So anyway, that's this section. You can do the homework now, so get after it.